Hello. One of the things that I've found about algebra is that students can do one-step equations. Most students can do one-step equations without any problems. Um, it's the three or four things that we add to one-step equations that students start to melt down with. If I give you uh, x plus 4 is equal to 12, most students remember this from pre-algebra. You get rid of your main objective is to get the variable by itself. So therefore you get rid of adding 4. How do you get rid of adding 4? You subtract 4. And by the law of equality, whatever you do on one side, you do on the other. And x is equal to 8. Most students say, hey, I know how to do that. That's no problem. And then we do x minus 12 is equal to 15. And we say, okay, how do you get rid of a negative 12? Well, you add 12. And the student goes, okay, and you do it on the other side, and everything's fine. Again, the student says, yeah, I can do algebra. 3x is equal to 12. Well, how do you undo multiplying by 3? You divide by 3. And if you do it on one side, you do it on the other. X is equal to 4. And the student's real confident now and says, there's nothing to this. We're in pre-algebra and we're moving along. X divided by 6 is equal to 12. Student goes, okay, well, the opposite of division is multiplication, so I'm going to multiply both sides by 6. And that gives me x is equal to 72. So at this point in pre-algebra, the student's going, I got this down, no problem. And then the teacher goes, well, we're going to add a couple of things to this, and we're going to call them multi-step equations. We're going to add the distributive law. We're going to add fractions, or combining like terms, sorry. We're going to add fractions. And we're going to add decimals. And with each one of these, the student's confidence decreases and decreases and decreases, or goes down each step. And this is where the student's confidence really takes a hit. So we're going to go through and we're going to talk about each one of these and then put them all together at the very end. Let's talk about what the main objective of algebra is. The main objective of algebra is to get the variable, get the variable by itself. That's the main objective. I also add another little objective, just me with my students. I tell students to try to keep the variable positive. That helps a lot. You can't do it all the time, especially with inequalities, but most of the time with equalities, you can move the variable to the left or right side to keep it positive. Let me give you a quick example and I'll show you what I'm talking about. And this pays off in inequalities later on after you get the multi-step equations. It pays off later on because if you keep the variable positive, you can keep away from some other rules that you might forget to do on a standardized test or a chapter test or whatever the case may be. Because memory and time is kind of your worst enemies on a test. And when you're freaking out because of time, you might forget to do the last couple of steps with a negative variable rather than a positive variable. So it's just kind of a little trick to kind of keep away from some of the things that you might forget to do. But here's a quick example. Let's say that 2x plus 2 is equal to 4x minus 6. And I go into this when I go over these rules up here, I go into this, and basically the 4x is bigger than the 2x. Now what's our main objective? The what? The variable. The variable. So we don't worry about this 2 and this negative 6. So I bring this 2 over to the other side, and it becomes a negative 2x. Now there's some people that start to have cardio, I don't know what you call it, but cardio arrhythmia or some kind of infarction when I do this, because there's a lot of teachers out there that say you have to move the variable to the left-hand side. Well, think of it as Jody and Susie on a seesaw. There's Jody and there's Susie. Jody's on the left-hand side. Susie's on the right-hand side. So if they go over to Susie's house and get on the seesaw, does that mean Susie has to sit on the same side as Jody? No. Doesn't matter. Susie can sit over here and Jody can sit over here. It is no law that says you have to put the variable on the left-hand side. And this keeps the variable positive, so you bring this over, that becomes a positive 6, and that becomes 8 is equal to 2x. And divide by 2, x is equal to 4. But trying to keep the variable positive, that kind of goes in up here. I'll go over that when we go over these 4 things that kind of mess you up with the multi-step equations. So just kind of forget about this. I was just showing you, try to keep the variable positive. That's kind of like my secondary rule or my secondary objective of algebra. So the first rule of algebra and the main objective of algebra is to get the variable by itself. Get the variable. It doesn't say anything about a number, it says the variable. You focus on the variable. Focus on the variable. Okay? Now, speaking of such, and I forgot to leave that out of the objectives, and we could call it step 0, keep the variable positive. Okay? And we'll go over that first. Now, I'm born and raised on a farm, still live on a farm, and you have to feed animals, and you have to put feed in buckets. Well, let's say that I hired you to work on my farm, and I have a barn, it has a door, and it has feed in there, and I tell you that I want you to go out to the barn, and I want you to get feed and feed all the horses and all the cows and all the goats and everything. And there's 2 buckets out there. There is a 2-gallon bucket that you feed with, and there is a 5-gallon bucket that you feed with. Now the 2-gallon bucket is about the size of like a mop bucket. It's easier to handle and it's smaller. The 5-gallon bucket is twice the size of a mop bucket. It's a little bit taller, a little bit wider, and it holds a whole lot more feed, but it's heavier and more bulky. Most people will pick the smaller bucket. Now, some of you may disagree with me and say, well, you can feed a whole lot more when you go out. Yeah, but I'm talking in general, just which bucket. If you go out and pick a bucket, which bucket do most people going to pick? They're going to pick the smallest bucket. Okay? Whenever you're dealing with a algebra equation, 2x plus 4 is equal to 6x plus 3. The bucket in the equation is the variable. So we're going to put a little bucket symbol here, and we're going to put a little bucket symbol here. Which one's a smaller bucket? Well, the 2x. The 2x is a smaller bucket. So that means you're going to move the smallest bucket. Now, when you move the smallest bucket, what are you doing? You're trying to keep the variable positive. Now, the reason I tell students to do this is, again, on a standardized test or on a test where you are timed, sometimes due to time, you may forget that, oh, I got to divide 3 by a negative and then I got to change the inequality. So there's 1 to 2 steps that you can avoid having to do if you keep the variable positive. Now, granted, there's sometimes you can't make on the inequality you can't. But on some inequalities you can't. But I'd say 99% of your equalities and your inequalities, you can keep the variable positive. And, as long as you know the other 2 rules, that's fine for when you can't, the 1% that you can't. But most of the time on a test, you don't want to have to remember 2 or 3 extra rules when you can avoid having to not remember them, but having to use them. So keep the variable positive by moving the smallest bucket. So you move that smallest bucket, and that becomes, how do you get rid of a positive 2x? You subtract 2x. And that gives you 4 is equal to 4x plus 3. And how do you get rid of a positive 3? You subtract 3. And 1 is equal to 4x. So therefore 1, or x, is equal to 1/4. Okay? So there's an example of keeping the variable positive. Always move the smallest bucket. So let's try another one. Negative 3x plus 2 is equal to 4x minus 7. Now again, you're focusing on these 2 terms right here. Why are you focusing on them? Because they have the what in them? They have the variable in them, and your objective is to solve for the variable, get the variable by itself, and keep the variable positive. So you do not really care about this positive 2 or this negative 7. They're kind of like, a kite has a what? Has a tail. Well, that tail is important, but that tail will always follow the what? The kite. These 2 numbers right here are the tail, where 3x and 4x is the kite. They're going to follow no matter what. You don't need to worry about this 2 and this negative 7. You need to focus on the variable. So, which one's the smallest bucket? Well, most of you should have said the negative 3x. So you bring it over. And that becomes a positive 3x. And that becomes 7x. So you kept your variable positive. And now you've got 2 minus 7. Now, if we're going to keep this variable by itself, then we got to move this negative 7. How do you get rid of subtracting 7? Well, you add 7. So add 7 on one side, you add 7 on the other side. And that becomes 7x is equal to 9 divided by 7 divided by 7. X is equal to 9/7. Now another little trick, another little thing you need to know here. Well, that's an improper fraction, Hubert. Well, that's fine. Improper fraction's fine, unless the directions tell you to change it. Most of the time they're not, because an improper fraction is fine. The only time you need a mixed number, most of the time, is with units of measurement, which are usually in word problems. So unless you have a unit of measurement, or unless you have directions telling you to change it into a mixed number, leave it as an improper fraction. And that's how you do the first thing, which is keeping the variable positive. Well, what about the second thing, the distributive law? Well, the distributive law, basically, It's kind of like a concrete block. Any of you ever worked with concrete before? Let's say you got a box. Let's say you're making stepping stones for your house or your yard or whatever, and you're taking pizza boxes and you're putting concrete in them, and you're making little stepping stones. And that box is about 1 foot by 1 foot by 2 inches. Okay, and I'm just showing you this so you can see. And you're working with the concrete, and you're putting little rocks in there, the pretty little rocks, and the kids used to make them. They have little fancy like fake jewels in them and things like that. And you're putting stuff, and you're making it smooth, and you're working with it, and your ring falls off. And your ring falls into the concrete, and you don't notice it until the next day. Well, that concrete is cured. And the concrete, when it gets cured, it gets hard. And when that concrete cures, you ain't going to get that ring back out of that concrete unless you what? Bust it up with a big hammer. So let's talk about what's our objective, what's our obstacle, and what's our tool. Our objective is to get the ring out. Our obstacle, I really don't know how to spell obstacle, is the concrete. And our tool is the hammer. Well, in algebra, you have the same thing. Let's say you have this example. 2 times x plus 2 is equal to 6. Well, here you've got a problem. You can't touch what's in here. You can't touch that x. You can't touch that 2. The x plus 2 is in a concrete block. Okay? And you need to make a note of that. The x plus 2 is in a concrete block. So you need to bust it up. Why you got to bust it up? Because your ring is the x. Your concrete block is the parentheses. And your hammer is the what? The 2. The action of swinging the hammer and busting up the block is called the distributive law. Distributive law is basically busting up the block. So I'll redraw it down here. 2 times x plus 2 is equal to 6. Your objective is to get the x out, but you can't because it's in the concrete block. So you got to take the hammer and you got to bust it up. That gives you 2x plus 4 is equal to 6. Remember, the distributive law is multiplication. Factoring is division. So there we go. I got a regular problem now. I got my x, and it's nice and sitting with that 2, and I can subtract that 4. And I get 2x is equal to 2. And 2x is equal to 2. I divide by 2. And x is equal to 1. So there is a nice example of busting up the block with the distributive law. So let's try another one. Three times x plus 7 is equal to 2 times x minus 1. So now we got 2 rings. We got 2 cement blocks. We can't do anything. Now, some people would say you could divide by 2 on both sides. Yeah, but that's not going to do anything. You could divide by 3 on both sides. Yes, but that's not going to do anything because you still got 2 cement blocks. So you're going to have to bust up both cement blocks. And to bust them up, you use the distributive law. And now you can bust the blocks up. 3x plus 21 is equal to 2x minus 2. Now, which one's the smallest bucket? There's a bucket, and there's a bucket. Which one's the smallest one? The 2x. So you're going to move it over. So that's 3x minus 2x plus 21 is equal to negative 2. Something else I also do, I call the equal sign the river. And when you cross the river, you turn into the opposite. Kind of like the zombies and people that are alive. You cross the river, you turn into a zombie. Okay, well, when you're here and you cross the river, it turns into a negative 2x. So that'll give you x plus 21 is equal to negative 2. And how do you get rid of a positive 21? You either subtract 21 from both sides, or you take it across the river and it becomes a negative 21, sorry. And that gives you x is equal to negative 23. And that's how you use the distributive law. Now, usually after you use the distributive law, usually you go into our third rule, which is combining like terms. Now, you can have combining like terms without the distributive law. It just depends on how the question is set up. Let's say that we have the following. 2x plus 3 times 2x minus 1 is equal to 4 plus x times 2 times x minus 2, and we'll leave it at that. Okay? Now, of course, you see as we add more things, distributive law, combining like terms, you start to see the problems get bigger, and that comes with territory. So the first thing I'm going to do, I can't do anything with those blocks because they're just like a 5-pound weight hanging on your ankle while you're trying to tread water. So we need to bust them up. And there is your distributive law. So now we've got 2x plus 6x minus 3 is equal to 4 plus 2x minus 4. Now at this point, I'm going to take my handy dandy red pen and I'm going to mark some things because they need to pop up when you do this. And usually when you use the distributive law, usually afterwards you're going to combine like terms. So these two right here are like terms. And these two right here are like terms. So your next step in this algebra equation is to combine the like terms. 2x plus 6x is 8x. And 2x, and what is 4 minus 4? Oh my goodness, they cancel out. So now you have just a regular equation. What's your smallest bucket? The smallest bucket is, that was my drum roll. The smallest bucket is 2. So we're going to bring it over. Oh my gosh. Now you're supposed to sit here and stare at it for 15 minutes because you don't know what to do. No. If I subtract 2x from 2x, what do I get? You get 0, Hubert. That's right. I'll even put a little mark through it so you'll know it's a 0 and not an O. And what's 8x minus 2x? 6x. And what are we going to do with this 3? We're going to take it over here, across the river, and it becomes a positive 3. And 6x is equal to 3, divide by 6, divide by 6, and x is equal to, x is equal to 1/2. So here you see the distributive law, and then you see combining like terms, moving the bucket, and solving the equation. So now we're up to 3 out of the 5. I'm going to do one more on combining like terms because I want you to see that you can combine like terms before or after the distributive law. 2x plus 3 minus 6x is equal to 4x minus 2 plus 6. Now here's an equation right here that has no blocks in it. It has no cement blocks in it. So therefore, what can you do? Well, you can go right to combining like terms. And this is kind of like cleaning up your room. You got all this stuff laying in the floor. You need to consolidate it and then put it on the shelf or put it in the toy box or put it in the closet or whatever the case may be. You got to consolidate. Or putting groceries up in the kitchen. You got to put all the canned goods together, and you got to put all the cereals together and all the refrigerated items together. Well, that's what this is right here. What is 2x minus 6x? Well, I'll just write it over here. 2x minus 6x plus 3 equals 4x minus 2 plus 6. Well, here is your combining like terms, and here is your combining like terms. So go ahead and do it. 2 boxes of cereal minus 6 boxes of cereal is negative 4 boxes of cereal. Plus 3 is equal to 4x. And then what is negative 2x? What is negative 2 plus 6? Well, you owe $2 and you have $6. So you have $4. All right, at this point, find the smallest bucket. So find the smallest bucket. Which one's smaller? The negative 4x. So you take it across the river, and it becomes a positive 4x. And we have 3 is equal to 8x plus 4. And how do you get rid of a 4? Positive 4. Take it across the river, and it becomes a negative 4. 8x is equal to 3 minus 4 is negative 1, and divide by 8. X is equal to negative 1/8. So that's an example. That's an example of using combining like terms with no distributive law. Usually, you have some questions that do it before or after. And then the last section is clearing fractions and decimals. The only thing I'm going to tell you to do here, I'm going to give you 2 laws. 1, when clearing fractions, multiply by common denominator. When clearing decimals, multiply by the furthest, I know this don't sound good, but place value. You'll understand when I explain. So let's do an example. Let's do 1/2 times x minus 2 is equal to 3/4 times x minus 6. Now at this point, after you have an anxiety attack, you're going to look at these two numbers. And you already know how to do fractions because either you watched my refresher on fractions, or you've taken my class, or you've taken a class on fractions. And the common denominator is 4. So you take your handy dandy magenta pen and you multiply this side by 4 over 1, and you multiply this side by 4 over 1 because the common denominator is 4. I'll put a baby step in here for you. So I'm going to put 4 over 1 here and 4 over 1 here, and then I'm going to rewrite my equation. 1/2 times x minus 2. 3/4 times x minus 6. And watch what happens here. The magic. 4 divided by 2 is what? 2. 4 divided by 4 is 1 times 3 is 3. And look at there. You have a nice pre-algebra problem that all you have to do is bust up the blocks. And that's 2x minus 4 is equal to 3x minus 18. And then you can solve accordingly. And I would be bringing that 2x over. That'd be x plus 18 to be 22, or I'm sorry, plus 18 to be 14. I think it's 14, but you can check me. Now what if you do if you're given a decimal? If you're given a decimal, you just count the place values taken furthest and multiply by that number. Example. Let's say you have 10.1 times, I don't know, 3x minus 2 equals 0.17 times x minus 1. Okay, so at this point, take my handy dandy red marker, this is to the tenths. This is to the what? This is to the hundredth. So the furthest place value is what? The hundredth. So I'm going to multiply both sides by 100. Now, of course, if you've had basic math before, you know that when you multiply by a 10 or 100 or 1,000 or 10,000, you count the zeros and you move the decimal place to the right that number of places. So there's 2 zeros, so I'm going to move that decimal place. Here it is right here. 1, 2. So I get a 10. One, two, 1, 2, 17. And there, again, magically appears a problem that you can do a whole lot more easier, or a whole lot more easy than you could if you were relying on a calculator working with decimals. So that'll give you 30x minus 20 is equal to 17x minus 17. This is the smallest bucket, so it goes across the river. That'll leave you with 13x. The negative 20 goes across the river, becomes a positive 20, is equal to 3. X is equal to 3/13. And that's how you clear fractions and decimals. So, I will supplement this video with a few more examples, but you can rewind and see whatever you missed, and hopefully that'll help you out on some algebra.